Hello everyone, thanks for having me. I'm Yining. I'm currently a lecturer from the Department of Computing Science, University of Aberdeen. And today I want to talk about my recent research, which is related to the machine learning for the future home healthcare. So the outline of today, I will firstly introduce the background and motivation of the home healthcare in UK, followed by our overarching vision, so what we want to achieve, what is our desired impact. And later, based on my own research interest and expertise, I will mainly focusing on the research gaps based on the computer vision and also the Internet of Things. And the most important part, we will introduce what we can do and what we have done so far, several of our undergoing projects. And finally, we will, based on the recently published the EPSRC health technology strategy, to talk about the potentials and opportunities we have. So this page is like a overall key factors which motivates the home healthcare. So it has been discussed a lot this morning. So because of the aging population and the old people prefer to receive the home healthcare at home because it can help to make sure their independence and also their social connections, and it can enhance the quality of life, and it can prevent the unnecessary hospital stays, and also it can help to support the hospital discharge. So the aftercare point of view, and it can release the competitive challenges of the NHS, and it is also supported by the policy. The UK government encouraged this kind of community-based healthcare. And here is our vision. So as you can see, the main idea is we want to put economical edge devices at the user's home there, and the user can use some of the wearable devices or some equipment to upload their measurements and also their personal requirement. For example, their mood and their kind of the mental issues through the app, and all these kind of information will be pre-processed locally at home, and then only the structured physical and mental health information will be uploaded to the centralized NHS server. And with this kind of vision, so we have 4 features. The first one is it can help us to collect data more frequently compared with going to the hospital in person. So in this way, so we can have early diagnosis and prevention and prediction. And also we're trying to make sure that the models, the AI models, are very lightweight. So all these kind of small data can be loaded to the edge devices. So with the people with more than one kind of disease, they can have their tailored devices to fulfill their own requirements. And because of the computing resources we need is quite limited, so it could be supported even without the stable network. So it can also enhance the equality of the service. And also we are not trying to replace the human being, the healthcare professionals, by the AI models, because it is kind of dangerous. So we always keep the human being in the loop to make sure that everything is in the safe area. So the research gaps, because I'm personally doing with the vision-based data, so I care about what kind of data can be captured by the cameras. So we have already discussed a lot this morning about the difficulty of gathering data, and especially if the caregivers are not professionals, it also have the problem of the poor data quality. So the image they capture at home cannot be as good as what we captured in the hospital, of course. And also if we have the frequently collected data from at home, so we are trying to utilize the time series data to check the changes between the different changes over time, to make sure that if there is any significant deviation, so that may indicate some of the physical or mental issues, which requires the intervention as early as possible. And also, one of the big problem from the image, medical image area is about the lack of the labeled data. Even if we have the image data, it's also difficult and very time consuming to label them. And from the model point of view, so instead of having the big models, the superpower servers, we're trying to keep the model lightweight and cost efficient. And we want the the model can support the multiple diseases in a modular way. And we also trying to make the model both personalized and also generalized. So there is always a trade-off between the personalized model and the overfitting problems. So then I will introduce several of our undergoing projects to show you what we can do. So the first one, let's go to the melanoma healthcare, melanoma aftercare. So next page, please. So the main idea for this one is we try to put as you can see, we have the image quality assessment model located in the edge devices in the patient's home, and only the high quality data will be passed to the centralized server, which is connected with the healthcare professional, the human beings. And this kind of structured healthcare database will feed into the temporal anomaly detection model to see whether the changes have been significant. The changes are significant enough to alert the healthcare professional to have the early intervention. And this one is still undergoing. We have a quick demo showing how we deploy these kind of small devices at home. So all this, so could you just play the video we have? It's a long video, but basically the main idea is we have this kind of app. So it is not supported by the very powerful server. It's only used like a palm-sized device. So just this size to support this kind of lesion analysis. So after doing that, you can see we can generate a report, see which level the melanoma is. So let's change to the next page to save our time. And as part of our overall vision, we also very care about the image quality assessment. So next page, please. So this work is based on the trying to do this kind of medical image quality with the no reference matter. So because of we haven't got the enough labeled data in the medical area, so we use the natural images. So for example, the images with the brightness, contrast, colorful, sharpness, this kind of label, and we try to train the label with the nature images, and it can be integrated. It can be generalized well in the medical image. So we only need very limited number of the labeled medical image, so we can do this kind of training and the testing. The next page, please. I don't want to be nerd, so let's skip this kind of mathematical methodology part. But if you are interested in this part, please just ask me later, and I'm happy to show you one step closer. So next page. So here are the data set I use. So the first one is the source domain, which is the nature image, and the target domain is the medical images. And we compare our result against the 12 state-of-the-art method. Next page, please. And as you can see here is the comparative performance from both the quality and the quantity point of view. So from the quantity point of view, as you can see, our performance is best in the two main matrix. And from the quality point of view, so we can give the scores with the medical image, and it's almost identical to the ground truth. So next page, please. So here is a more advanced work about the image quality evaluation. So this one, we use the zero-shot learning. So we no longer need any labeled medical data. So we just give the description we need. For example, we need the data with the sharper edges, and we want the data to be brightness and with the high contrast. So we just give the description like this without feeding any labeled data. So it can also achieve very good results. So so here is a typo mistake. So it's not the source domain, it's the target domain. So we don't need any source domain. So the model is already there. We just test it in the medical data, unlabeled medical data directly. And as you can see, the results still good. So the first one is the retinal data, and then the span data, and followed by the melanoma data. And here is the quantity and the quality results. The next page, please. So this one is about the semantic segmentation. So we're trying to detect the lesion. Next page. So this one, we proposed a lightweight network for the diabetic retinopathy. And as you can see, the next page, please. So skip this nerd stuff. And we use tool of the data set, which is available nowadays. And also we have the benchmarks It's okay. So here is the quantitative results. As you can see, our proposed method achieved the best results compared with the state of arts, and it can help us to detect 4 types of the lesions in the retinal images. So next page. And here is the visual result. So this is the quality results, and the second column is the ground truth. So what is we are trying to achieve, and our proposed one is the third column, and all the rest of this are the benchmarks. As you can see, our proposed method achieved very similar results as the ground truth. So here are some like play around projects. So it's not supported by any founders, but I just do it for fun. So the first one is the biological age estimation for the mental health monitoring. As you can see, we still use very lightweight devices. This is the Raspberry Pi. It costs only less than 100 pounds. And here, as you can see in the video, so we can check the age and also the emotion. So we are trying to detect the significant deviation that can indicate the underlying physical and mental health issues. So the next page, please. So the last one is, next page, please. The last one is about the 3D pose construction. As you can see, we just input the images, we just input the videos, and the videos will detect the visual and the body detection, and then it will feed into the recurrent GAN network, and we can estimate the pose contraction from the front and also the side. The next page, please. So here is the like a summary what we have talked about today as the released by the EPSRC Health Technology Strategy. So they identify several of the key points, and we find that there are a lot of opportunities of doing the home healthcare based on the lightweight models with the lightweight devices, and also the hand holder devices, which can help us to tackle this kind of aim. So if you are interested in these topics, please feel free to let me know. And thanks for today.